Good morning all. Now I am going to explain about stability analysis. Okay. First of all, what is meant by stability? Stability is nothing but here a bounded input produces and bounded output. Okay. Then the system is stable. Otherwise, then the given system is unstable. That means if a bounded input will produce an unbounded output. Okay. Next, coming to the properties of stability. Okay, all poles are located on left half of S-plane, then only the system is stable. Okay, see here, let us consider a transfer function. Transfer function is equals to S into S plus 1 by S plus 2 into S plus 3. Okay, here it is a transfer function, right? That is G of S by 1 plus G of S into H of S, right? Now see here, this numerator, that means transfer function can be written as numerator divided by denominator, right? Numerator terms are nothing but zeros of a transfer function, whereas denominator is nothing but poles of a transfer function. Now see here poles. Here S plus 2 and S plus 3 are the poles, right? That is S is equals to minus 2 is one pole, S is equals to minus 3 is another pole. Okay, that means these all poles should be located on left half of S plane, then only the given system is stable. Okay, next, second point, if all poles are located on purely imaginary axis or origin, then the system is marginally stable. Marginally stable means, suppose if we consider a transfer function, that is S into S plus 1 by S square plus 1. Here poles are nothing but S square plus 1, right, is equals to 0. Then S is equals to plus or minus j omega, right? Okay, if I draw the pole 0 plot, okay, that means this here it is plus j omega minus j omega. Okay, right? That means when poles are located on imaginary axis, okay, then the system is marginally stable. Okay, suppose, next point, see here, if multiple roots on imaginary axis, then the system is unstable. That means, see here, same transfer function is equals to S into S plus 1 by S square plus 1. Here poles are located on imaginary axis, right? This is marginally stable system. Suppose if the transfer function is S into S plus 1 by S square plus 1 whole square, that means repeated poles, that means S is equals to plus or minus j omega 2 times is repeated, right? That is plus 2 j omega 2 times minus j omega, and repeated poles on imaginary axis, then the system is unstable. Then the system is unstable. Okay, next, if multiple or single poles are located on right half of the S plane, okay, then the system is unstable. Okay, that means if transfer function is equals to S into S plus 1 by S minus 2 into S plus 3. Now see here S is equals to 2. That means this is S is equals to 2. That is in right half of S plane, right? Right half of S plane. This is right half, this is left half. That means here the given system is unstable. That means it will produce a unbounded output. Okay, now see here, to find out the stability, we are using here Routh-Hurwitz criteria. RH criteria is used to find the stability of any control system. Okay, already we know that transfer function is equals to G of S by 1 plus G of S into H of S. Okay, to find the stability, we need to consider characteristic equation, that is in denominator, that is 1 plus G of S into H of S is equals to 0. Okay, next, coming to the conditions. Okay, necessary conditions for the RH criteria, all the coefficients should be present. This is first one. Next, second one is all the coefficients should be present along with S power nth term. Okay, now see here all those points. Assume the characteristic equation, that is nothing but 1 plus G of S into H of S. Assume a power n into s power 4 plus a power n minus 1 into s cube plus a power n minus 2 into s square plus a power n minus 3 into s power 1 plus a naught or a power n minus 4. Representation is our wish. S power 0 or s power 0 is nothing but 1, right? Is equals to 0, right? Okay. To find out the stability, all coefficients should be present. That means s power 0 term should be present in the characteristic equation. S power 1, s power 2, s power 3, s power 4. That is the necessary condition. If any term is missing means that is a unstable system. Okay. Next, second point is all the coefficients should be present along with s power nth term, right? That means this is s power 4, right? This s power 4 is also having some coefficient, s cube also having some coefficient. Every coefficient should be present. That means every s power n power term should be present. That means if here s power 4 is started first, right? That means s power 4 should be present, s power 3, s power 2, s power 1, s power 0. After that, this coefficient should be present. Okay. Then only RH criteria is applicable. Otherwise, then the given system is blindly, that is unstable. Okay. After that, sufficient condition is in case of RH criteria, all the first column elements should be positive. Okay. Okay. To check the stability, all the first column elements should be positive. Okay. Now we will see how to find the stability of any system. See here, first problem. What is given? Directly is given characteristic equation, that is 1 plus g of s into h of s value is given. Okay. For this type of problem, first you have to write s power 4, s cube, s square, s power 1, s power 0. In this way you have to write first. Okay. You have to write first s power 4 term coefficient, next s square, next s power 0. That is first s power 4 coefficient is 1 into s power 4, right? That is 1. S square, that is 3. Next 1, right? Next s cube, you can start from s cube coefficient, that is 2. Next 2, right? 2, 2. Next no term is present, right? 0. Now see here, for this type of problems, first of all you need to consider first 2. 2 into 3, right? 6 minus 2 into 1, 2 divided by 2. You will get 6 minus 2 divided by 2. You will get 4 divided by this value is 2. That means here value is 2. Next, similarly again 2 into 1, 2, right? Next 0 into 1, 0. 2 minus 0 divided by 2. You will get 1. Okay. For your understanding purpose, I am writing again clearly. S power 4, s cube, s square, s power 1, s power 0, right? 1, 3, 1 first row, second row 2, 2, 0, right? Third row value will be, first one is 2, second one is 1, third one is no third element, means that is again 0. Next, for this element again same process, right? 2 into 2, that is 2 into 2, 4, right? Minus 1 into 2, 2. 4 minus 2, 2 by 2 you will get 1. Next 2 into 0, 0 minus 0 into 2, 0 divided by 0 by something, always 0, right? This is s power term, right? Next s power 0, 1 into 1 minus 0 by 0 into 2 by 1, right? That value will be 1. 1 into 0 minus here also 0, right? 0 into something by divided by 1, you will get 0. Okay. To find out the stability, okay, see here, this is first column, right? Okay, this is the first column. Okay, all coefficients of first column should be positive. There is no sign change, right? This is positive, this is positive, this is also positive, this is also positive, and this is also positive. That means here all poles are located on left half of S plane only. Then the given system is stable system. Okay, in this way we can find out the stability. Okay, similarly next problem, s power 4, here also is given characteristic equation. Suppose in the problem, if he is given transfer function, that is g of s by 1 plus g of s into h of s, right? Transfer function, that means you can directly equal denominator value and equals to 0. See here, s power 4, s cube, s square, s power 1, s power 0, right? First I have to write s power 4 coefficient, that is 1. Next s square 3, next constant 5, right? Next s cube 2, next s term 4, that is 2 into 3 6 minus 4 into 1 4, that is 6 minus 4, 2 divided by 2, you will get 1. Next 2 into 5 10 minus 0, right? 10 divided by 2, you will get 5. Next 1 into 4 4, right? Minus 2 into 5 10, 4 minus 10 minus 6 by 1, you will get here minus 6. Next 1 into 0, right? 0 minus 0 into 2, 0 divided by 1, you will get again 0, right? Next minus 6 into 5 minus 30 minus 0 divided by minus 6, you will get here 5. Now see here, in first column element, here positive 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 negative positive, that means from s square to s power 1, one time sign change, right? Positive to negative sign change is one time. Next again from s power 1 to s power 0, negative to positive, second time sign change. That means here in first column element all elements should not be 0, sir, should not be positive, right? Hence it is a unstable system. Okay, in the examination point of view, you may ask find the number of right hand poles. Okay, number of sign changes is equals to number of right hand poles. Okay, how many sign changes are there? 2 sign changes, right? Then 2 right handed poles are there. Okay, next problem, s power 4, s square, s power 1, s power s cube, sorry, s power s square, s power 1, s power 0, right? Again 1 4 1, next 1 4, right? Now see here, 1 into 4 4 minus 4 into 1, 4 by 1, that is value will be 0. After that here it is 0, right? 1 into 1 1 minus 0 divided by 1, you will get 1. Okay, see here, if see here 0 element in first column, suppose if there is any 1 0 in the first column, it is replaced by epsilon. Now this value is replaced by, I am replaced by epsilon, right? Then do the same procedure again. 4 into epsilon, you will get 4 epsilon minus 1, 4 epsilon minus 1 divided by epsilon, right? Next epsilon into 0 minus 0 into 1 divided by epsilon, that value will be 0, right? Again 4 epsilon minus 1 by epsilon into 1, right? Minus 0 into epsilon divided by 4 epsilon minus 1, that means you will get here also 1. Now see here, in this term substitute epsilon value is very less value. Here our assumption is 0, right? Actually here you are getting 0, right? To get some value here, I am assuming very less value, 0.04, right? That is 4 into 0.04 value means very less value here. That means this value will be negative. Otherwise in numerator you can substitute 0. Okay, otherwise in numerator if you substitute 0, you will get negative value, right? That means here this resultant value will be negative. That means here sign changes will be first time and second time, right? Then the given system is unstable system with how many right hand poles? With 2 right hand poles. See here s power 4 means how many poles are present? 4 poles are present. Two right hand poles means what about left hand poles? Remaining poles are left hand poles. That means the left hand poles are 2 poles. Okay, in this way we can find the stability. Sometimes maybe you may get direct questions like this. Find the stability. S plus 25 equals to 0. Right, S is equals to minus 25, right? This system is stable system. S square plus 9 is equals to 0. S is equals to plus or minus J3, right? Okay, poles are located on imaginary axis. That means marginally stable. Next, S square plus 10S plus 5 is equals to 0, right? If we calculate roots, minus b plus or minus under root b square minus 4ac by 2a, right? That is minus 10 plus or minus under root b square 10 square 100 minus 4 into 1 into 4ac 5 by 2 into a value is 1, right? That means approximately minus plus or minus j into some value, right? That means minus, for example, assume this value as minus 10 by 2 5, right? Minus 5 plus or minus j something value. This means this minus 5 value is located on left half of S plane, right? Hence it is also a stable system. Okay, next, S power 4 plus 3s square plus 4s plus 1 is equals to 0. See here s cube coefficient is missing, right? Hence the given system is unstable system. Okay, next, s cube plus 9s square plus 4s plus 10 is equals to 0. By using RH criteria you can simplify this problem. Okay, thank you all.